Anchor installations for manufactured homes need not be a complicated procedure. However, there are certain steps that an installer must follow in order to ensure that the homeowner has adequate windstorm protection. The model installation standards now spell out the minimum requirements for setting all new HUD code homes. Our testing has shown us that anchors must be used properly to provide the holding power required by HUD, state, and local agencies. Currently, there are many different anchors certified for use in anchoring homes. Ground anchors range in size from 30 inches to 60 inches long, with single and double helixes. The helixes are 4-inch to 8-inch in diameter, plus there are several specialty anchors for rock, asphalt, and concrete applications. Before you start any home installation, be sure you check with local officials for the requirements in your area. Anchors derive their holding power from the ground they are installed in. This is referred to as the cone of influence. The cone starts at the helix and expands out and up at approximately a 45-degree angle. The cone for a 30-inch anchor contains 19.85 cubic feet or 2,400 pounds of soil at 122 pounds per cubic foot. Obviously, for the shorter anchor to reach the 4,725 pounds of holding power required, it must be installed in hard-packed Class II soils. The 48-inch anchor has a cone of 80 cubic feet with a potential of 9,800 pounds of holding power. However, in loose soil conditions, the anchor can still lose its grip as the soil breaks away much easier. In all our travels, the most common installation error we see is the use of smaller anchors in medium to loose soils that require a larger and longer anchor. The soil test probe is used to determine the soil conditions below the surface near the anchor's helix. Using the soil test probe will ensure maximum anchor holding strength by indicating the proper anchor model for each soil condition. The test should be conducted in the same general area that you plan to set your home. Warning: before any ground anchor installation, always determine that the anchor locations around the home will not be close to any underground electrical cables, water lines, sewer piping, or gas lines. Failure to determine location of electrical cables may result in serious injury and fines. Begin by placing the probe tip into the ground where you intend to place the anchor. The tie-down drive machine adapter head has a socket inside that can slide on top of the soil probe for easy installation. A 15/16 inch or 24 millimeter hex socket with a ratchet or breaker bar can also be used to rotate the probe in a clockwise direction. Drive the soil probe into the ground to the desired depth for the anchor. The probe has colored markings at different lengths to determine the depth. Once the probe is at the desired depth, place wrench adapter onto torque wrench and insert hex portion of wrench adapter onto earth probe. Support the probe shaft with one hand while rotating probe with the wrench. Read the torque wrench while rotating the probe clockwise. The torque value is the highest number achieved before the probe spins freely. Using the soil classification chart from the model installation standard, cross-reference probe readings by matching color codes printed on tie-down's torque wrench. After finding the values of the torque wrench, use the soil classification chart to determine the soil class and proper anchor to be installed. A reading above 550 inch-pounds is described as Class II soils. A 30-inch anchor with twin 4-inch helixes and a 12-inch stabilizer plate are the most common combination for this installation. Class III soils have a reading of 351 to 550 inch-pounds. A 36-inch anchor with 12-inch plate is the most common for these soils. A reading of 276 to 350 inch-pounds is classified as 4A soil, and a variety of 36-inch and 48-inch anchors and plates are used in these soils. Class 4B soils have a soil reading of 175 to 275 inch-pounds. This requires the use of a 60-inch anchor with minimum of a 7-inch helix and a 17.5-inch stabilizer plate. Remember that when readings fall below these values, a professional engineer should be consulted before any installation begins. Proper anchor installation. There are two common methods of anchorage based on the wind zone location. Vertical or uplift anchorage is used in wind zones 2 and 3 with strap from the anchor attaching straight up the wall of the home for maximum strength. The second being lateral or frame tie method, used in most Zone 1 setups. These straps are installed at an angle requiring the use of a stabilizer to be effective. The 45-degree or inline method is commonly thought to be the strongest of the frame tie installation methods. However, two conditions must be met to provide the holding power required. First, the anchor must be in line with the strap being installed and attached to the home. That is, the helix is directed away from the home, and this usually requires that the anchor be installed before setting the home. The second condition is the use of an anchor longer than the soil test probe chart has indicated for this installation. When the anchor is set at a 45-degree angle, it loses part of the cone of influence used to hold the anchor. A common error in anchor installation is leaving the anchor head above the ground level. Tests have shown that the anchor will fail at less than 700 pounds of side load. When tension is applied, the rod simply bends over, causing the home to fall off the foundation. An anchor is never to be left in this position. Even with the anchor head installed flush with the ground, the anchor cannot provide adequate holding power. While the helix will do its job of holding the bottom of the anchor in place, the rod will knife through the soil or bend as tension is applied. Anchors require some form of stabilization to be effective. Using a stabilizer plate does not add to the holding power if the anchor is left above ground level. The rod has room to bend over the plate, allowing failure in the system. The proper way to install an anchor is with the stabilizer plate and the anchor head flush with the ground level. We will cover this in greater detail in a few minutes. While we are discussing ground anchors, it should be pointed out that the cross-drive or rock anchors are not designed for hard soil or rocky conditions. These anchors are designed for use in solid rock. When used in hard or rocky soils, the rods will bend with less than 700 pounds of side load or 1,000 pounds of direct load, a far cry from the 4,725 pounds of holding power required. As discussed earlier, frame tie anchors must be stabilized to keep them from bending or knifing through the soil, or installed in line with sufficient length to hold 4,725 pounds. The most common anchor stabilizer is the 12-inch steel stabilizer drive plate, but several other steel and plastic versions are also approved. A concrete collar measuring 12 by 12 by 18 can also be used to stabilize the anchor. The proper installation of an anchor starts with the setting of the anchor at a slight back angle from the home. The anchor is installed leaving 16 to 18 inches of the anchor exposed. The stabilizer plate is installed straight up and down, slightly in front of the anchor. The anchor is now installed the remainder of the way into the ground. Using the slotted bolts and strap, pre-tension the anchor until the anchor rod is flush with the stabilizer plate. Use only strapping that meets the ASTM specifications for stretch and breaking strength, approved for manufacturer home installations. When using a frame tie, the hook or buckle must start on the upper inside corner of the I-beam. The strap is then brought around the frame and over the strap on top of the I-beam and down to the anchor. The strap should always come from the top of the frame to reduce flexing of the I-beam. To attach the strap to the anchor, pull the strap past the anchor head 12 to 15 inches and cut with snips. Insert the strap into the slot of the bolt until flush with the opposite side of the bolt. Using a 15/16 or 24 mm ratchet, wind the strap around the bolt a minimum of 4 to 5 turns to adequately tension the strap. Continue tightening until the anchor head is flush with the stabilizer plate. This gives the system the proper pre-tensioning required for holding power. A side load of 700 pounds on a home directs a vectored load of 1,000 pounds on the strap and anchor when installed at a 45-degree angle. As the angle increases, so does the force on the strap and the anchor. At 53 degrees, a 700-pound side load translates to over 1,100 pounds, and when installed at 60 degrees, the direct load doubles. This increased vectored force is the reason we recommend that you stay at a 55-degree or less angle with the strap installation and when the angle exceeds 45 degrees, an additional frame strap must be attached to the opposite I-beam. In this animation, the wind applies side load pressure to the left side of the home. The anchor on the left, or windward side, does all the work, and the strap on the right side of the home goes slack. When any of the installation guidelines are not followed, the home is put at risk of sliding off the foundation piers and causing severe damage to the home. When the anchor moves more than the 3 inches, the blocks will tilt and slide apart. Testing done at Tie Down Engineering shows there is tilting of blocks prior to sliding apart. Now we are ready for proper anchor installation. Using your torque reading for the soil, determine the proper anchor for your install. Drive the anchor 2/3 of the way into the ground at a slight back angle and install the stabilizer plate straight up and down approximately 6 inches in front of the anchor. Finish installing the anchor into the ground. The new standards require that when installing strap, it must be protected at sharp corners by use of radius clips or other means. You can use tie-down strap protector, or some installers cut a piece of strap and bend around the beam to protect the strap. Install the strap starting on the inside upper lip of the I-beam and rotate around the beam back over and the top and down to the anchor. Cut the strap 12 to 15 inches past the head of the anchor. Insert the strap in the bolt until flush, and strap must not be more than 1/4 inch through the bolt. Using a 15/16 or 24 mm socket, wind the strap around the bolt 4 to 5 turns to adequately tension the strap. A speed wrench can be used to hold the bolt in place and make this step much easier. Adjust plate depth so that the anchor head is snug over the top lip of the stabilizer plate. Continue tightening until the anchor head is flush with and pre-tensioned against the stabilizer plate. Another change in the standards is the longitudinal stabilization. All homes must now have some form of longitudinal anchorage. The most common form is a bracket and tie strap. Attach the bracket to the bottom of the I-beam with the plates bolt to the upper plate over the I-beam. The strap would be installed with one of the corner bolts coming out of the back towards the end of the home, thus giving lateral and longitudinal stabilization for your home. Remember to check with your state and local laws or codes before installing any anchor or foundation system. For further information on anchor test or products, contact Tie Down Engineering at 1-800-241-1806.